Okay. Hi. First of all, I would like to thank the organizers for inviting me to give this talk, in which I'm going to present the result of work that has been conducted primarily by Alex Rigano in my lab, but with close collaboration with David Grunwald and the DCIC group. So Micrometa app is an application that that was intended to facilitate the collection of microscopy metadata compliant with the requirements that were initially defined by the 4DN imaging working group in the first phase, and then now it's truly becoming a community standard that is being evaluated by a larger and larger group of people to reach consensus around it. So this work has been pretty exciting. So the origin of this work came from the realization that emerged from the first phase of 4D Nucleome, that in order to upload data, imaging data, this data needed to comply to certain minimum information standards that would facilitate its comparability. And initial tests were done by imaging the same slides across different groups, and it was realized that it was very difficult to compare, but this was definitely across these different instruments or operators, even though the slide that was imaged was the same. But this is definitely not a unique situation in 4D Nucleome. And so, in fact, we all know that there is a reproducibility crisis, and in imaging, this is particularly difficult to tackle. And that is what the work that the imaging working group from the first phase embarked on. And just to give you another indication of how important this work is, a recent work came out by a group led by Mark Sanders on eLife that talks about really the current status of how material and methods are really under-reporting the details about how imaging experiments are conducted. And these people did a thorough evaluation of 240 papers and from different fields. And even though on average 52% of these papers would have imaging figures as one of their important, so they used imaging as one of their as a centerpiece of their research to reach their conclusion, only 7% of the method section was dedicated to imaging, and only 15% of these papers would meet a minimum standard that these authors define. So, I mean, this is depending on what they thought of it, but I still think this is a very important information to keep in mind. And primarily, a lot of the information that was included in the material and methods were not sufficient to reproduce. And in addition to, obviously, the need for further training and education, the importance of accurate metadata was really highlighted by this group as a possible solution. So we are definitely doing something that is really important and is emerging as more and more in the community. Just to remind people, what we are doing is we are defining microscopy standards, and that means you've already seen a permutation of this in my previous talk, but essentially it means three different things. The file formats and the open microscopy environment are now developing new next generation file formats to facilitate the collection of complex data, such as, for example, the ones that will be generated in the second phase of the 4D Nucleome. The other big aspect is obviously defining what we want to capture in the metadata, provenance and quality control. And the third part is what we're talking here is tools that are going to be used to collect this information and capture it and store it in these containers, so that it's going to be easier, or on data portals like in the case of 4D Nucleome, so that it's easier for people to do this without having to go insane, because these are very complex things and we want to make it as easy as possible. So the model that emerged from 4D Nucleome now has been basically embraced by a number of different international organizations, and it essentially says, we have to microscopy metadata is the hardware specification, the image acquisition settings, and the quality control metrics. All of this together with the pixel data, is essentially one unit that is essential to be able to then reproduce the experiment, and especially if one has to do analysis. But in recognition to the fact that there is different possible complexities, and the recognition that one wants to have minimal reporting guidelines, so something is disturbed. Anyway, I'm going to continue. So the tier, so we define different tiers that would essentially subdivide the different experiments along 3 dimensions: the microscope complexity, the type of experiments, and the analysis results that one wants to do. The original number of tiers were 5, and now we have reduced them as part of the BINA revision to 3 tiers. And I would say that the majority of the 4D nucleome experiments for the second phase will probably fall in tier 2 or tier 1. Tier 3 is really just for the people that produce the microscopes. So
Caterina, sorry, can I ask a quick question? This is all light microscopy you use here, no? There's no other, there are other EM-based methods. This does not capture any of that. This is all light microscopy in terms of...
Yeah, so what we are... This part here is only light microscopy, but we should keep in mind that as part of the EBI Eurobioimaging effort, there is actually a new paper coming out, and David and I are authors on it, in defining the requirements for example, in that particular case, for defining the requirements for deposing on Bioimage Archive, which is this effort originating from EBI in Cambridge. In that case, they are defining not only light microscopy. So this is, one could consider this the light microscopy part, but it could definitely be connected with other standards defined obviously they would have to be done by communities that are experts in EM. So in our case, this is just a light microscopy, but we were just discussing yesterday actually with this group called QUAREB, Quality Control and Reproducibility for Light Microscopy, that emerged recently and is led by Roland Nitsche from German Bioimaging. And this group contains now 142 people, many manufacturer representative, bioimaging organization. And yesterday I presented our proposal. So the 4DN-BINA proposal was presented to this group, and there is a working group on metadata there of 40 people, and they were very, I was a little nervous before I presented it, but they were very encouraging, and they thought, they basically, it does sound like this effort is actually going in the direction of becoming the foundation for a community standards, which is quite exciting. And the open microscopy environment people who are defining the standards for storage of all of the information are very supportive of this effort. So, and they're very supportive of the fact that this model, these guidelines that are community driven, will eventually end up, once it's been accepted by everybody, it will end up in the actual OME containers that they're developing. But in order to capture all this information, one has to first, it's not trivial. Right now, most of it is not captured automatically. It is not stored automatically on the image headers. So there has to be some effort done, and we want to minimize that effort to collect that information. And in a number of applications, I'm very excited because there are a couple of different applications, and we're all really working together to make sure that all of them are working together. This method J2 is a new application, and I'm not going to tell you about, but I'm a co-author in this paper too, in which this is actually taking care of automatically writing method sections based on the 4DN-BINA model. OME is another application, and Micrometa app, and we're really making a huge effort to make sure that all of these applications are compatible with each other. Micrometa app brings to the table basically an idea of facilitating the interactive and intuitive ways, an interactive and intuitive way of collecting metadata by dragging and dropping different components and entering attributes that are required based on the different tiers that I described before. So that one only is required to enter information and is required by the specific tier that is considered important to reproduce that kind of data. So this Micrometa app was developed by Alex Sirigano in my lab and has two sides. One side is the definition of the data of the hardware components. This has to be done only once for each microscope you're going to be using. So the beauty of it is that once you produce this Microscopy JSON file, you can reuse it over and over again for all the different data sets you're going to produce using the same instrument. This part is already available on the data portal. And for example, in this case, I'm showing you an example of a microscope that was used to acquire images for the Coleman lab in phase 1. I'm going to give you I think I have time to show you a little bit of a demo. So if you go to the data portal, you're going to find yourself under tools. You now have, this is still an alpha version because until we submit it and publish it, we're going to call it alpha. You find yourself in this landing page. You can connect to a documentation page that tells you step-by-step instruction of how to use it. You click on the page, and you can create a new microscope using one of the tiers. This is still, we haven't updated to the new set of tiers, so it's still 5 tiers, but that's going to be done soon. And you can also load an existing microscope. And let's say a use case could be that you have purchased a new objective, and you want to document it. So you enter the objective, you decide that this is going to be done at tier 2, and then you enter the information for this objective. And then the application tells you which fields are required for that tier. Sorry? Is there a problem?
I think somebody is not muted.
Okay. So you enter the information that are required. And then you confirm, and assuming it's meeting the validation tier, it lets you save it. And now it's become green so that you know that everything here is validated. You can then save it, and it will be saved in on the portal. So let me see. I lost the track of the time. I think I still have at least 5 minutes, but
yeah, you have another few minutes.
Yeah,
absolutely. Go ahead.
So the second part of the workflow is the part that we're still developing. So it's in progress. And the point is that you have created a microscope JSON file that is defining the microscope you're going to be using for your experiments. Now you're going to select it. You're going to select the imaging data set you want to upload. And then you're going to be guided through entering the information that the application cannot find in the image header. The application uses already bioformats, which is the library that is used to interpret the headers of multiple different file formats from multiple different companies. Actually, currently, it's able to, at different level, read 150 different formats. This is developed by the Open Microscopy Environment people. But a lot of this information, the information often are not sufficient to meet, for example, a certain tier level. So then you have to enter additional information, and the application will guide you through by highlighting in red what's the information that are missing. One of the most complex part will be to define your light path. And some of these, in this case, for example, we already defined the different components that are part of the light source, the detector, the light guide and stuff, but we still have to define the filter set. So we select on the dichroic position. We select a specific dichroic among the ones we have entered in a microscope file. And then we are now I entered it, and we can then confirm once everything is become green and we have collected information. So this is, again, a facilitated way of doing it that bridges the gap between the information that comes from the headers of the file and the information that is required for reproducibility. And of course, where we are leading to, and why I'm very excited about the fact that we are now part of this Quareb LIMI community, in which a lot of different manufacturers are part of this discussion. Yesterday, for example, there was we had a lot of questions from one of the Zeiss representatives, and they are starting, because there is so many of the members of the community that are pushing for this, and they are part of the discussions. We are hoping that this is going to become part of the standard that manufacturers will automatically record in the header of the files. But for now, because we're not at that position yet, we have an application like this that allows you to enter information that is missing. I should also say that this application is being piloted at UMass Medical School by David Grunwald this year as part of the course for training new students on the use of microscopes, and they're gonna. So I'm very excited that these other way of using the app for educational purposes is going to be tested, and and it sounds like it might be a good way of teaching people how to build the different components, how to not build the different components, but to become aware of what different components are essential for a microscope and what each one of them does, and becoming very aware of all these different aspects. So I want to remind people that there is a Micrometa app website and also documentation that we have written, and don't hesitate to contact us to ask us about any question you might have. And thank you so much for your attention.